Hey lovelies. Okay, so I brushed my hair, so I'm gonna do a quick video. All right, so I had promised you guys a video sometime back, like way back. I hate holding the camera, whatever. I had promised you guys a video sometime back based on something I had posted on my Facebook, talking about what's the difference between heat, what heat does to protein, and what formaldehyde does to protein. And I said nothing, it does the same thing. All right, so I'm gonna quickly tell you guys what I meant by that. So basically what heat does to protein and what formaldehyde does to protein is they create cross links, right? And cross-link, or a cross-link molecule, is just basically where you take where two molecules or two polymers are joined together chemically by an ionic bond. Okay, and two polymers just mean two molecules that are made from monomers. So you take monomers, building blocks, you put them together kind of like Legos, and then you construct the molecule, right? That's a polymer. You take those two, one polymer, and you join them together. And you have different ways you can join them together. You can do it with a chemical agent, you can do it with heat. There's various ways to do it. Okay, but basically it's you have those two polymers come together via an ionic bond, and that's what cross-linking means, right? So in this instance, I'm talking about proteins, right? And I'm saying to you that formaldehyde and heat creates cross-linkage in proteins. Okay, now the reason that's a big deal is because you don't have enzymes to break down that structure, that molecule structure that you just created with the heat. You don't have any way to break that down. So once you eat your heated protein, whether it's animals or whether it's in plants, it's the same. It's done to varying degrees because basically it's clearly it's worse in an animal product because you have more concentrated protein structures in that product, right, versus a plant product that is mainly based off of amino acids, right? But you're still doing it to some degree when you heat the food. All right, it's just really bad in the animal-based products. And in the animal-based products, you create something else. You create cross linkage and you create another structure. I'll talk about that very quickly later. But it's a big deal because you can't break it down. Okay, you don't have any enzymes to break it down. You don't have an ability to break that down. So you eat it, right? And what happens is it's absorbed, and it's recognized by your body as a foreign invader. That's why I said to you sometime back, I referenced this, but I didn't explain why. Every time you eat protein, especially every time you eat protein that you heat, okay, every time you eat protein, it's your body sees it as an invader. Okay, if your body didn't make that protein, it's gonna attack it. All right, you make your own proteins. You don't eat proteins. You make your proteins, and you make them from the amino acids. You don't make protein from protein. You make protein from amino acids, and you have code in your cells called your DNA that codes for the type of proteins that are specific to you, what you need. All right, you can't like people eat collagen thinking that they're like you don't eat. It doesn't work like that. Anyhow, your body sees that as a foreign invader and it mounts an attack. This is considered normal. Okay, people that eat regular diets, I'm not talking about people that eat mainly raw foods. People that eat regular diets, when you look at their body, when you measure their body temperature, it rises after a meal. And it rises after a meal because it's mounting an inflammatory attack on the meal that you just ate. People think this is normal. Okay, not because everybody's doing it means that it's normal. There's a lot of things that society does that's normal. It's a normal response to an insult or an injury that you are causing against the body. Anyhow, you mount an inflammatory attack and your body goes after it. And so every time you eat, right, because everybody cooks their food and everybody's eating meat, and so every time you eat, you keep mounting over and over and over and over again this inflammatory response, or this immune response to the meal that you ate. You can't break down that protein, and I've told you before that your body does not have a mechanism to store protein. It either uses it or it gets rid of it. A good chunk of the protein that you guys are eating is not being used. I've said this over and over again. It's either being converted to carbs in some way, shape, or form, or it's being taken out by the kidneys, the liver and the kidneys. Okay, the liver has to detoxify it, and then it's going to be handled by the kidneys. The body does not have a storage mechanism for protein. That's why I said that heavy protein diets really is like the antithesis for health when it comes to your kidneys and your liver. Okay, so that's number one. If you don't understand how strong cross-linking is, I'm going to explain to you, I'm going to take you on the side of formaldehyde, right? And the reason I understand formaldehyde so well is because it was a part of the industry that I worked in. It is the backbone of pathology. I was a pathology manager for many years, and I could tell you right now that formaldehyde is at the backbone of what we do in histology. Okay, it's at the backbone of what your embalmer does whenever it gets a dead body. Okay, when you embalm, formaldehyde is the main star in the embalming fluid. Okay, they perfuse every part of the body by injecting it into the circulatory system so that it gets to all the cells, so that it can do something that we call in the industry tissue fixation. Okay, we want to fix the tissue, and really what that means is we want to preserve the tissue. We want it to make it so that the tissue does not break down. Now in histology, we get body tissue all the time. Okay, that's what histology is, and we have to examine it for disease. That's what the doctor is doing, that's what the pathologist is doing, and he's going to read a result out and give the report to your clinician. All right, in order for us to be able to examine the tissue, it has to be fixed, meaning it has to be protected from degradation. It needs to be protected from breaking down, from putrefying. That's what tissue fixation is going to do. And the way we achieve tissue fixation in the lab is via the use of formaldehyde. The way formaldehyde works is it creates cross linkage between the protein that can't be broken down. That's how we fix tissue in the lab. Now, after we fix the tissue in the lab, we run it through various processes where we dehydrate the tissue, and then we infiltrate it with various substances to make it hard, and then we cut it, slice it really thin, and we stain it, and we do all these different things. We run markers on it, all these different things we do in order to examine the tissue. But none of that, we cannot do any of that if the tissue is not, if those cross-linked proteins have not been established first. Okay, this was a very big deal in histology because a lot of times clinicians that send us tissue don't really understand the science behind this, and they won't put the tissue in the we call it formalin, not formaldehyde. And the reason we call it formalin is because we don't use it at 100%. Okay, it's that good. We don't have to use it at 100%. We use it at 10%, only 10%. The rest is 90% water. Anyhow, when a clinician took tissue, we need them to put that tissue in the formalin right away, and a lot of them wouldn't do it. A lot of their staff wouldn't do it. The nurse staff that was there when they did the procedure, they wouldn't put the tissue in the formalin right away, and we could tell because the tissue would come, you could just tell, right? Anyhow, that was a big deal. That was a big fight between, I was amazed at how much doctors didn't realize. Some doctors thought that it was like we were just talking about the Loch Ness monster, like it wasn't actually important because they didn't understand the actual science behind it. Like, no, you have to fix the tissue. Tissue fixation is like key. It's paramount. If you don't do it, we can't examine the tissue. Anyhow, after the tissue is fixed, we run it through a bunch of processes, chemical processes. In the lab, I could reverse all those processes. But the one thing I couldn't reverse is tissue fixation, because once you create those cross linkage, you don't break them. They can't be broken down. Now they are developing chemical ways to break that down, but naturally there is no way for you, the human being that's creating all these cross linkage in your proteins when you cook them. There's no way for you to break that down. Okay, it doesn't exist. We even use heat in the lab to fix tissue, by the way. And that's another agent we used in the lab too. Other than the formalin, we'd put it in the formalin, and if we wanted to speed up the tissue fixation, because tissue fixation, the rate of fixation, it takes time depending on the structure of the tissue, how much fat is in the tissue. Fatty tissue need more time, blah blah blah. Okay, if we wanted to speed that up, and we do, We put it in a processor, and the processor speeds that process up by using heat. Okay, I'm just telling you, we used heat and formalin to fix tissue to speed it up. All right, another thing we used to use too in the lab with that use heat, microwaves. Yeah, if the tissue is small enough, we could just pop it in the microwave with the agent, and it would work just fine. We could get the tissue fixed within minutes. Not a big deal, right? Now, do you understand what I'm saying when I say to you that it's very important to understand what you do to the food? Okay, you are engaging in chemistry when you cook your food. You are engaging in biochemistry when you cook the food, and most people are not aware of that. And that's one of the big reasons I stay away from heating foods. Okay, because you do it to some degree to every food that you heat. Another cross-link structure that you create that everybody was talking about the other day, it was in vogue, nobody's really talking about it right now. It's called AGE. Okay, what I was talking about before was cross-linkage between two proteins. What was all the rage, AGEs? They were referring to cross-linkage between a protein and a sugar. Okay, and the best example of this that most people know about is called acrylamides. Okay, when you cook, when people were talking about this, when you barbecue your meats, for instance, and you create that nice char or that burn, that's acrylamides. Okay, when you cook the substance at a high heat, you're creating acrylamides. And what you're doing, the reason it's a problem is because you are creating a cross-link between a protein and a sugar that cannot be broken down. They cause problems in the body, and they cause problems in the cell, and they are known to be cancerous. Everybody knows formaldehyde is cancerous, okay, but nobody understands why. Not nobody, I mean the general population, the general public does not understand why formaldehyde is a problem. And I'm telling you, it's very well known. This is basic science. We know why it's a problem, at least in the scientific world. It's because of the cross linkage and the fixation that happens in the tissue when you use formaldehyde, where you're doing that to your food every time you cook it, and you're doing it especially to your meat every time you cook it. That's why AGE agents, okay, like acrylamide, that's why those things are a huge problem. It's the cross linkage that you're creating that cannot be broken down, and the way that the body responds to that. All right, so I do have a reason why I don't heat my foods. I have a reason why I minimally engage heating my foods. Okay, and this happens, like I said, to some degree. It happens in the foods, in all the foods, whether it's vegetables, whether it's grains. It really does happen pretty high in grains, because grains, now you're looking at starches, and especially if it has gluten in it, now you're looking at creating those structures between your starches and your protein, your gluten, right? Because gluten is a protein. So I really don't mess with the cooked food like that. I'm telling you guys, you're not doing yourself any justice. But I'm just giving you the information, and it's up to you to decide what you want to do with it, okay? But that's why I personally don't engage in the cooking of my foods. And if I do, it's very minimal, and it's very sparing, and I do it at low heats. I don't engage in the frying. I don't engage in any of that stuff, okay? Because I looked with my own eyes for years and worked with fixed tissue, and I know that is not, you can't just bring that back. You can't bring tissue fixation back. So that's why I said what I said when I said on Facebook, do you understand the difference between what you're doing with your foods when you heat it versus what formaldehyde does? And basically, it's not much of a difference, okay? All right, my lovelies, I gotta go. Bye. I hope that helps someone.